Good afternoon, students. This lecture is in continuation with the previous lecture. Today's topic is glassy states. The glassy states of material refers to a non-equilibrium solid state such as is typical of inorganic glasses, synthetic non-crystalline polymers, and food components. Characteristics of the glassy state include transparency, solid appearance, and brittleness. In such systems, molecules have no ordered structure and the volume of the system is larger than that of crystalline systems with the same composition. Okay? These systems are often referred to as amorphous solids or liquids. Glasses are generally formed by melting crystalline materials at very high temperatures. When the material cools, the atoms are enclosed in a random state before they can form in a perfect crystalline arrangement. There are various types of glassy states. The first type includes it is characterized by the cessation of the vibratory movement of rotation of the molecules in a definite temperature region. This results in stabilization of the chain structures of rigidly associated polar molecules. In second type, it consists of organic glassy polymerization products. These glass in the stabilized state have fiber structure of rigid valence bonded carbon atoms with a small lateral branches in the form of hydrogen atoms or more complex radicals. In the third type, most extensive type of glassy state consists of refractory inorganic compounds of multivalent elements. These glasses in the stabilized state have most thermostable chemical structure in the form of the three-dimensional rigid atomic valency bonded spatial network. Next topic is solid and crystalline state. Now crystalline solids. What are crystalline solids? A crystalline solids possesses rigid and long range order. In the crystalline solid, atoms, molecules or ions can occupy specific positions. Means in crystalline solids, the atoms occupy a specific position. An amorphous solid is defined as a solid which does not possess well-defined arrangement and long-range molecular order. Means in crystalline solids, the atoms molecules have specific positions. In amorphous solids, the atoms molecules do not have specific positions. Okay, they does not possess a well-defined arrangement and long-range molecular order. You can see a unit cell. It's comprised of the repeating structural unit of crystalline solid. Okay. Next, you can see a crystal lattice of sodium chloride, that is NaCl. How the atoms and molecules are arranged. Sodium and chloride atoms are arranged in the crystalline lattice. There are 7 basic unit cells. First is simple cubic, second is tetragonal, then orthorhombic, then rhombohedral, then monoclinic, triclinic, trigonal and hexagonal. These are 7 crystalline systems. Type of crystal. There are various types of crystal depending upon the forces that hold the units together. Units means that hold the atoms and molecules together. First one is ionic crystal. Ionic crystal includes the electrostatic force of attraction. Various properties are these are hard, brittle, have high melting point, poor conductance of heat and electricity. Examples you can see in this slide, that is NaCl. Second is covalent crystal. The forces holding them are covalent bonds. As the name indicates, covalent crystal. The forces are covalent bonds between the atoms and the molecules. They are hard, have high melting points, poor conductor of heat and electricity. Example is carbon, silicon oxide, that means quartz. Third is molecular crystal. In molecular crystals, the forces holding them together are dispersion forces, dipole-dipole forces, hydrogen bonds, and general properties are they are soft, they have low melting point, they have poor conductance of heat and electricity. Examples you can see argon, carbon dioxide. Then fourth type of crystal is metallic crystal. Metallic crystal, as the name indicates, they consist of metallic bonds, and their properties are they are soft to hard, they have low to high melting point, they have good conductance of heat and electricity. Examples you can see in these slides, examples are all the metallic elements, all the metals like sodium, magnesium, iron, copper, etc. Next topic is amorphous solid. I have students already told you about the crystalline solids and amorphous solids. An amorphous solid does not possess a well-defined arrangement and a long-range molecular order. Amorphous substances as well as cubic crystal, they are isotropic. Isotropic means they exhibit similar properties in all directions. And there are various properties of amorphous solids. They do not have definite geometrical shape. In these solids, particles are randomly arranged in different three dimensions. Okay, the particles have no ordered arrangement, they are randomly arranged. They don't have sharp melting points. Amorphous solids are formed due to sudden cooling of liquid. Okay, when we cool a liquid, then sudden cooling of liquid occurs. Then this is an example of amorphous solid. Amorphous solid melt over a wide range of temperature. Next topic is polymorphism. Polymorphism, as the name indicates, I'll explain you this. Like some elements such as carbon, sulfur, they exist in more than one crystalline form. They are said to be allotropic. Allotropic, or in special cases we can say as a polymorphism, means when a substance exists in more than one crystalline form. जब एक substance एक से ज़्यादा forms में exist करेगा तो हम उस substance को बोलेंगे polymorphism. Process क्या होगा ये? Polymorphism. Okay? Polymorphism is the ability of the substance to exist in more than one crystal structure. Polymorphs, when two crystals have the same chemical composition but different internal structure. Okay, modifications or polymorphism or forms. Now pseudo polymorphs, it's another term I have used. Different crystal forms have molecules of the same given substances and also contain molecules of solvent incorporated into a unique structure. These are called as pseudo polymorphism. Next, in this slide, students, you can see the example of polymorphism. Like you can see diamond and graphite. Diamond is a metastable form. It converts very slowly to the graphite. So this is the example of polymorphism. Thank you.